Hello everyone, and welcome to another remote sensing lecture video. And in this lecture video, I want to finish up our discussion talking about indices by going through an actual example with an image snippet and a spectral profile of NDVI. So if you remember our discussion with NDVI from the last video, it was this idea that you could take the near infrared and red regions and you could manipulate them in such a way to get an indice that ranged from -1 to 1, with 1 meaning very high reflectance in NIR and very low reflectance in the red, and -1 meaning very high reflectance in the red and very low reflectance in NIR. And then they would range to 0 as the radiance values came closer together. So what I want to do is I want to go through this example. This is the same thing that we did when we talked about the ratio of just looking at a spectral profile, an image, and some pixel values, and talk about what we would expect to see and what we actually see. So just like before, I want to talk about what we're actually using here. So again, just to sort of recap, right, it's NIR minus red over NIR plus red, right? This is the equation, right? This is NDVI, right? So we need the NIR and the red region. And just in case you've forgotten, right, we're dealing with that same Landsat image that we've been dealing with forever, right? The NIR band is this band 5 right here. So this is NIR. And the red band is band 4, which is this band right here. Okay, so as always, we have the green representing vegetation, we have the blue representing water, and then we have the gray representing an urban area. And this is the calculated NDVI, which you can see in this case we didn't quite make it to -1, but we did actually make it to 1. So that somewhere in the image there's a pixel that has virtually 0 red reflectance. But anyway, let's talk about what we're dealing with here. So let's talk about vegetation first. Right, so vegetation, right, has high reflectance in NIR. Right, that's what this means here, relative to the red. And it's got relatively low reflectance in the red, right? That's what this means to have this slope be like that. You have higher reflectance in the NIR than you do in the red. So what would we expect then this equation to look like? We would expect the NDVI, right? Again, as red gets smaller and NIR gets bigger, right? This top number tends to go towards NIR. This bottom number also tends to go towards NIR, which means that this is going to turn to 1. So we would expect this to be closer to 1, right? We would expect this to be closer to 1. So let's look at some actual values here. Right, so we have 3666 minus 246 divided by 3666 plus 246. Right, if you do the addition on that and the subtraction as well, you end up with 3,420 on the top and 3,912 on the bottom. And then if you do the division, you end up with 0.874 approximately. Right, so we're getting pretty close to what we expected, right? We expected that it would have a higher NDVI value, and 0.874 on a scale of -1 to 1 is actually pretty high. Okay, let's talk about water for a second. Water, again, looking at the same bands, we have the NIR band here and we have the red band here. Water is fairly low in NIR. It's also fairly low in red. Now, There's a little bit of an uptick here in NIR, so it's not going to be, they're not going to be exactly equal. Red is slightly higher. Or sorry, NIR is slightly higher. Right, NIR is slightly higher. So we would expect then, based on this, right, this is going to be close to 0, right? Because they're similar in value, but NIR is slightly higher, so it's going to be close to 0, but a bit higher, right? Because NIR is greater than red. This is not going to be exactly 0, but we're going to expect it to be closer to 0. So let's go ahead and do that math. 173, again, taking the NIR, we're subtracting the red, which is 110, over, so let me move down just a little bit, over 173 plus 110. If you do the math on that, you get 63 on the top and 180 and 283 on the bottom. And if you do that math, you get approximately 0.22. Okay. So this is actually closer to 0 than the vegetation is. So now I want us to scroll back up just a little bit here. And I want us to look at this image, this clipped little piece of imagery that we have here. So this is the actual NDVI values. Are we getting what we're expecting? So this is the blue point. So again, we go from negative, so negative 0.67 is the really dark, and the bright white is going to be a value of 1. So things that are closer to 1 are going to be brighter white, which 0.874 corresponds to this, which is in a region of generally light gray, versus this 0.22 is going to be somewhere, in roughly in this area here, maybe even a little lower, right? Which it does, right? This is a darker gray, almost black region. So our values actually do make sense here. So hopefully this made sense. Hopefully we were able to understand how seeing the spectral profile gave us an idea of roughly what we were expecting to see, then actually calculating it, having that match up with our expectations, and then how everything fed back into the image. If any of this didn't make sense, I encourage you to pause the video, go back, rewatch the part you're confused about, and as always, please reach out. Thank you.